So open your notes to the page that says the intermediate value theorem. And we'll go from there. So I'm going to explain it in words first. All right, so when I got up this morning, it said it was 61 degrees and there's supposed to be a high today of 80. You know, that's supposed to be a very nice summery day. Because temperature can't hop, like it doesn't just hop from 70 to 80 in an instant. It's what's considered, like you have to pass through 72 degrees, right, on your way from 70 to 74 degrees. You might do so very quickly, but it's a continuous function. So I know for sure today that if right now it's 61 degrees, and if when I go home it's 80 degrees, it had to be 71 degrees at least once. Does that make sense? That's what the intermediate value theorem says. It says as long as a function's continuous, it has to pass through every y value on its way from one to the other. It can do so more than once. So, for example, driving today here. Again, speed is kind of continuous. I don't jump from 30 to 40 or my car would lurch, right? I have to go through 32 miles per hour. So it just says that as long as a function's continuous, and that's called the hypothesis. So we're going to write that down. So if, and I'm going to go a little slower today than usual because, not because it's difficult, I just want to make sure you get the gist of it. If f is continuous, and then leave some space over here because we'll put a graph over there. So if f is continuous on, let's go draw a graph. Some interval from A to B. So let's go over here. Let's just go in the first quadrant, A to B. All right, so it says if a function's continuous on an interval, remember what that means? You don't lift your pencil physically, and then there's 3 criteria that have to hold on the whole interval, but that was from last Thursday. So if f is continuous on a, b, then let's go chart right here, and let's end our travels over here. Now there's lots of ways I can travel without lifting my pencil from A to B. But if I don't lift my pencil, don't I have to hit every y value, right? And maybe even twice, like right here at this y value, I hit it 2 times right here and right here, actually 3 times. So, but it says at least once. So let's go put what these values are over here. This would be called the y value at A, and this would be called the y value at B. So we have A, f of A, B, f of B. All right, so as long as I didn't lift my pencil on A, B, then for all, and we call it K, and I want you to go like this. K is a y value in there. So this symbol in math, so then for all K, with K between f of B and f of A. So you have to make sure the function's continuous, and you have to make sure that the y value is between them. Like I woke up, it was 61 degrees. When I go home, it's supposed to be 80 degrees. It could have been 58. Like it could be right now, but I'm not guaranteed it, right? So then for all K in this interval, let's go put a K right here on the y-axis. It says there has to be, so I'm going really slow so you understand it with the, if you were to Google this, it'd look really confusing. But does the temperature make sense? You have to pass through all of these on your way from here to here at least once if you never lift your pencil. All right, then, okay, I've got to get back where I was. F is continuous. Then for all K in between, there exists at least one, and they say it's a C. At least one C. Now C has to fall between A and B. All right, so the time There's at least one time today while I'm at work that the temperature has to be 72 degrees if I go from 61 degrees to 80 degrees, okay? And there'd have to be some time where that happened. So the math symbol for in the interval is that. It's an epsilon symbol. It means element of or in the interval. So there has to be at least one C between A and B such that f of C equals K. And that's a lot of math notation, don't you agree? The concept's super easy, but being able to write it is what gets a little tricky. I'll make sure we've practiced it enough times. One of these on the test is going to be worth 5 points because you have to hit 5 things when you write it out. Charlie's going to know for sure whether the answer is yes or no, but then it always says justify. So you're going to have to make sure that you know how to write it. But before we do that, let's talk about when you can and can't apply it. So here you go. It says, is there some value between -5 and 2? So I'm going to go, we're looking in here. Is there some value between -5 and 2 such that f of c equals 2? Remember, this is the y value when we talk about f of c. And you can see here's y equals 2. And it did happen one time. So that's a yes. So it did happen, but it wasn't guaranteed by the IVT. Tell me why not. Which of the things that we wrote is not happening on the interval from -5 to 2? Because it says, does the IVT guarantee one? There is one, but were we guaranteed one? And the answer is no, and I want you guys to tell me why or why not. What's the problem with it, Jake? There it is, on the interval in question, right? There could have actually been an open dot right here. The discontinuities can cause an issue, so you're not guaranteed. So no, F is not continuous, and then it's on the interval from -5 to 2. If the discontinuity is, outside of the interval, we could still apply. All right, so let's take a look at this guy. It says, is there a value C from -1 to 5? So now we're looking at these x coordinates from -1 to 5, such that f of C equals 2. What's the answer to that? Yes or no? Is there a y value here that got mapped to 2 in that interval? The answer, they're shaking their head, so no. Now, what part of the IVT wasn't guaranteed? 2 is not between. So this y value, this temperature, if you want to think of it like that, is not between 61 and 80. It's up at 90. Could it be 90 today, though? Yes, you're just not guaranteed it. So there's 2 things. What Jake said over here, that the function has to be continuous on the interval, okay? And the second thing is that the y value you're trying to guarantee falls between. The temperature falls between. So think temperature, all right? 2 is not between f of -1 and f of 5. So there's 2 situations where you can't apply it. We're more concerned about when you can. But I'm going to reiterate, what 2 conditions must be true? What's one thing that has to happen? You already said it. Yes, on the interval. So f must be, so that's the first thing you check, because if you can't apply it, you don't want to spend time applying it. On your homework today, if the answer is no, because the function's not continuous, well then stop. And say no, the function's not continuous. So that's nice and easy. Must be continuous on the interval given. So we're on this one, we're going to verify continuity first. Let's try it. All right, so we'll go to this one next. F of x equals this rational function. It does have an issue. It has a discontinuity, right, Felicia? Where is the discontinuity for this function? It has a problem. At x equals, yes, she's going to the denominator. Remember, the denominator being 0 is the issue. X equals -2, there is a discontinuity there, correct? Do you guys know what kind? Is it a hole in the graph? A removable discontinuity? Or an asymptote, a non-removable? And you're nodding, it's an asymptote, right? How do we know for sure it's an asymptote? So we talked about all this, you guys listen, right? How do we know for sure it's an asymptote, Harrison? Yeah, there's a 0 on the bottom with a -2, but a number on the top. So we're going to the infinities. So although there's a discontinuity, is it in the interval? No. So we can start with this one and say f is continuous on, right? So it must be continuous. This one I'm going to keep going, but I have to check the second criteria. Remember what has to happen. This value that you're trying to guarantee on the y-axis, which we call K, I'm going to have you put a little K above there, it has to fall between. So the temperatures have to fall between the high and the low for me to be guaranteed that, all right? So K has to be between f of B and f of A. The notation, Felicia, is what makes this hard, but the concept's so easy, right? If Charlie goes from 40 miles per hour to 80 miles per hour, he had to pass through 61 miles per hour. Could he have gone 30? Yes, but it's outside the interval. We're not guaranteed. That's really what it says. I like to get it out of the calculus. Sometimes if people are absent, they hop onto YouTube and they'll go watch videos, and it can be really complicated when it's just like a college professor doing the bare bones math. Because all you see is all these K's and F of A's and F of B's. It's actually really easy. By the way, listen carefully. This is one of the first of 3 what we call existence theorems. How many? We're going to have 3 the whole year. They're all first semester. They are called the IVT, Intermediate Value Theorem is what it stands for. I forgot to even tell you what it stands for. The Intermediate Value Theorem. We're going to have an Extreme Value Theorem and what we call a Mean Value Theorem. There are 3. But the way you always know that an IVT or MVT, one of these existence theorems, is what they're testing you on is it says, explain why there must be a value. That's always in the prompt, like there must be. So let's go over here. First of all, f is continuous. We got that going for number 1. Second, I have to evaluate what's happening on the endpoint. So I have to figure out what is f of 3. So I'm going to say f of 3, if I were to plot it, is at 0. Let's go to a graph and go 1, 2, 3. F of 3 is 0. By the way, I know like what Felicia said that there's an asymptote at x equals -2. Ava, is this making sense so far? It's really complicated if you're not paying attention, but otherwise it's super easy. All right, the next thing I'm going to do is go see what happens at -1. All right, so I'll go plug a -1 in there. It looks like I get a -4 over 1, right? -4, I hate arithmetic. But -1, 1, 2, 3, 4. There it is. By the way, because there's an asymptote there, I can see I'm heading to the infinity, right? That's where I'd be going if I were to graph this on a graphing calculator. Over here, it's going to look like that. Anyway, it says, are you guaranteed that you had to hit 2/3, oops, 0, negative, I'm sorry, it was -1, -4. I neglected to see, that kind of fell into my equals. It actually looks like this over here. Are you guaranteed some place where f of c is 2/3? Here's the start, here's the end, 2/3 is running right through here. Am I guaranteed that it'll hit 2/3? It might, but I'm not guaranteed it. All right, and here's why. So it says, state what, why or why not, if we can apply the MVT. Can't apply. It's not because the function's not continuous, though. It's because 2/3 is not between, what were we, 0 and -4. That's all you have to write. All right, does that make sense, Mallory? All right, so you're checking 2 things, continuity on the interval. Let's go look at number 2. Immediately I'm going to say no. Tell me why. I cannot apply the intermediate value. Tell me why, Dylan. Not continuous, and make sure you say on the interval. And that's one thing I said, College Board's really picky about how you write it. Like this one wasn't continuous either, but I wasn't on the interval. This guy, you're going to say no, can't apply. And this function is f, is not continuous. You're going to say where? So let's say at x equals -2. I'll slow down. And then this is how I would write it. Don't write which is in the interval. You can go like this, which is an element of. That means it's in the interval, -4 to 1. Done. So here's two where you couldn't apply it. The first one for this reason, the second one for this reason. So are we good on when you can't apply it? What do you think? Lily, you good? All right, awesome. They're nodding. So let's talk about, I feel like you're going to get this pretty easy. We're not going to do this one. Let's go to the next page. We're nearly done. It's a nice short day for notes. Maybe you'll even finish homework in class. So now let's go take a look at this one. All right, first of all, number one, in our head, we check for continuity, discontinuity, another asymptote at x equals 2, but it's outside the interval, so it passes test number 1, right? Test number 2, I have to go see where the end temperatures are. 1 hour from now, it's 1 over -1, right? 1 hour ago, it was 1/3, correct? Did I do my arithmetic right? I hate arithmetic. Is -1/2 the value I'm trying to guarantee between those two? What do you think? Is -1/2 between -1 and 1/3? Yes, so I can apply it. This is where it gets tricky, how you write it. All right? Copying the key for the homework's deadly in here. If you're like, I get it, I'm just going to go copy what she wrote. You're going to miss stuff. First of all, these are worth 5 points on your test, and I only give you 1. And I'm going to star over here because I'm going to change this to the type I put on the test even. So I'm being very transparent. All right, here you go. Since, this is how you write it. Wait, so this would be a yes. Because remember the prompt was, can you apply the IVT? This is a yes. IVT can be applied. Here's why. Since, what's the first thing you're going to state for getting your first point? You don't get a point for the yes, even if it's right. Isn't that weird? Right? Because that's a 50-50 guess. Colin Forth, brilliant. Anytime it's a yes-no question, or is this continuous or not continuous, and Harrison says not continuous, even if it's not continuous, you don't get any points. Unless it's multiple choice. Right? Because it's a 50-50 guess. All right, so what's the first thing I'm going to state right here to get my first point? Since? Awesome. F is continuous. And you have to tell me that it's continuous where? Awesome, you guys. On the interval. You've never written math before. And in calculus, we actually write math. The concept's so easy. How much easier is this concept than like the trig identities in chapter 6 of pre-calc where you are doing trig proofs? This makes sense, right? The temperature has to be 72 degrees today because temperature is continuous, and 72 is between 61 and 80, the highs and the lows. All right? It makes sense, but writing it is what's going to be tricky. Since f is continuous on the interval, then we had to verify that the -1/2, and you can just write it like this. You can even say with -1/2 less than or equal to, greater than or equal to, -1 and 1/3. So you're telling me that that temperature is between the two extremes on the interval. So there is, by the way, you'd get 1 point for evaluating the ends, 1 for the continuity, 1 for stating that you're recognizing it's between the intervals. So this is how it gets graded. The next one is for stating the theorem, because how many did I say there's going to be? 3. So you're going to have to state which one this is. Today, it's all the IVT. And it will be because we don't learn the other two for about another month or 2 or 3. But by the end of the year, you're going to have 3 of them. And so you have to say the intermediate value theorem guarantees, and this is the point a lot of kids don't get, like they don't earn. There's always lots of 4s out of 5s when I grade this on a test. You earn points in here, I don't take them away. So it's usually this last point, how you state it. What does the IVT guarantee? That's what's tricky. You're gonna write. You can go look back. Turn the page back. It guarantees at least 1, right? At least 1 time when the temperature was 72. But what are we going to call that time? At least one C. Where does C have to fall? C is on the x-axis. Guarantees at least one C or one time between, oh, I left it, like 6:30, yeah, exactly. At least one C between A and B. Some people say, are they closed or open? I'm going to say they should be open. But you wouldn't get docked like if Charlie went like this, because when we do the reading for the AP, they said we can't dock kids for brackets because some kids' brackets are so messy you can't tell if they're solid or wimpy. They call them parenta brackets, and you get credit. So they don't want you to not earn your calculus point because we can't figure out if that's open or closed. You get the general gist. It technically should be open, though. It's in the interval. All right, such that f of c has to equal -1/2. You always conclude it with what it says. There, looks, it's an easy concept, right, Langman? I always want to call you Jamie. Is it Jamie? No, it's not. Jessica. That's the other sister. I'm going to name the other sister. I've had all her sisters multiple times. Johanna. Oh, I knew it. I loved all the sisters too. We were buds. Did you know that? Your sisters and I. All right. Anyway, that one's done. How did it go? A little rough, but easy concept. How do we write it? So now over here, I'm going to do one more. I think that might be all I do. Yeah, I took one off the AP exam. We're nearly done today. Very short day. Get to work on your worksheet. So I'm going to make a different function. I'm going to call it G. I'm going to make it a cubit. X cubed minus 2x plus 1. All right. So are you guaranteed, I'm making this up as I go, so I'm trying to think it through, a 0. This is what the IVT is actually used for. It's the programming behind, you know, on your calculator in pre-calc, when you would go graph something, and they'd ask you for the zeros, and you'd go graph it, and then you'd go to the calc option and do calc 0, and it'd say get to the left and get to the right. Remember doing that? So it'd say, like, get to the left of here, and you put enter, get to the right of here, you would hit enter. As long as the function that you entered in your y value was continuous, right? And as long as 0 falls between, I've sometimes accidentally been too far to the left and it said no sign change. Does that ever happen to you, like on your calculator? And then you're like, oh crap, I'm not on both sides. So it's used, and that's, the IVT is the computer programming behind calc 0 on your calculator. Isn't that weird? Kind of weird, right? All right, are you guaranteed a 0 on the interval? And let's go from -2 to 2. Now keep in mind, I just wrote this off the top of my head. In my head, here's what I had to do. I had to present you with a continuous function on the interval, did I? And this one actually is continuous for all real numbers. I also had to make sure, by the way, when it says a 0, that's a y value of 0 or a y equals 0. It's the x-intercepts of a graph. That's what you might even want a 0 means an x-intercept. All right, sometimes kids are like, what do they mean a 0? It's when the y value is 0. Does that make sense, Felicia? So here's the deal. What you're going to do is, first of all, continuous, yes. What's the second thing you're going to do? The continuity can just be in your head, right? You'll explain it later. But what's the next thing I need to do? Go ahead and tell me. Yeah, I'm going to evaluate where I am at the endpoints. Okay, so I'm going to go like this, f of 2. Let's put this here so you know this is where my work starts. You'll get a point for evaluating these correctly. So whoever said evaluate the endpoints, you'd earn 1 out of 5. Okay, f of 2 equals 2 cubed minus 4 plus 1. It equals 5. So on that cubic, it sails through the point 2, 2, 5. Next step, f of -2 equals -8, -2 cubed, and then I'd be plus 4, so -4 plus 1, which is -3. So at -2, I'm down at -3. Wouldn't you agree that if this is continuous, I have to cross the x-axis, right? Because you can't have a sign change from positive to negative without hitting 0. Should make sense, right? So that's 1 point. Now you guys tell me how you earn the other 4. Somebody besides Jake, because he told me this one. There's 1 point. You knew to launch and figure out the endpoints. Now you're going to start. What are you going to say? Yes or no? Yes. That doesn't get you the point. Yes. Somebody else now. Let's piece it together. What do you think, Johanna? There, she got a point. Since f is continuous, but what should she add to that just to be really thorough? On, excellent, -2, 2. We're now at 2 out of 5 points. Right? Are you with me? The answer being yes is obvious. Yeah, hello, I have to pass through 0. I went from a negative to a positive, duh. Right? Easy concept. Peyton, so we've got the next point for the continuity. What's up next? Yeah, and she actually said something that I'm going to meet right now. Say we have to get it out of our vocabulary. Pronouns are not accepted. All right, so you said it, but I get it. All right, just don't write the word it, right? Like what your it is. What is your it that's between the what? The 0 that we're trying to guarantee is between, what 2 numbers are you going to put? -3 and 5. Now, if this had been a 2 and a 5, we're not guaranteed a 0. It could be, but I'm not guaranteed it, because I don't know, okay? So there's another point. What did I say the 4th one comes from? Yes, since f is continuous on the interval, with 0 falling between my 2 endpoints, what's the 4th point? That's stating the theorem, the IVT, and you can abbreviate. That's nationally known or mathematically known to be intermediate value theorem. You don't have to write it out. The IVT guarantees. Now see if you can write that last thing, because like I said, that's the point people miss. Usually lots of 4s out of 5 for what the last thing they write is. Remember, it guarantees a C, or you can write an X value, but we call it C. See if you can earn that last point. And you can write but technically you should write at least 1, because it could happen more than once. Now, where is that C? What do you think? Charlie, what did you write? Where's that C?
0.
That's what I'm trying to guarantee. So the C is the place on the x-axis between the interval in question where I get a 0. So C is always on the interval. So C's got to be somewhere between -2 and 2. Such that, all right? What a lot of words, right? Not one of my favorite days of teaching because this is kind of dry. I'm super excited to get into derivatives in a week or 2, but such that f of c equals what? I was guaranteeing at least 1, 0. There, 5 for 5. Now, it doesn't have to be word for word like that. You just have to hit the 5 targets. Does that make sense? So last step before you go to work is usually this gets tested on the AP exam. I took one off in AP FRQ actually. We're going to have a whole unit of study called particle motion. It's going to be about things moving. It's going to be very physicsy. How many of you are in AP physics? None of you. Interesting. Usually I get a whole chunk. Anyway, it says a particle moves along the t-axis, so now t is time like it usually is in the real world, and it's a continuous function. That's important, because if it didn't state that, I can't conclude. Based on the data in the table, must there be a time at which the particle is at rest? If something's at rest, what's its velocity? 0. Are you guaranteed at least one spot where v of t was 0? If the function's continuous. What do you think? What does your gut tell you? What do you think, Ava? Did it have to hit 0 if it went from 10 to -2 to 11 to 13 continuously? What do you think? Yes. A minimum of how many times? 2. It could have done more, right? This is just a screenshot of time. It could have, like between these two, it might have gone up, down, up, down, up, down, like a million times. You don't know. But for sure to go from 10 up here to -2 down here, it doesn't matter where you have to pass through 0. So let's answer it. Yes. Okay, that's a 50-50 guess. Now, what are the two things you have to say? Since velocity, speed, is the absolute value of velocity, but since v of t is what? Continuous. Now I'm just going to write that. With, now look at what, let's just go verify that somewhere in here it has to equal 0. We've got v of 1 equaling 10, and v of 4 equaling -2. Zeros between the two. Do you guys know the symbol for therefore? Have I used it in your video notes before? Yeah, the 3 dots, you're perfectly allowed to write that if you want to shorten it up. Therefore, the what? What theorem? IVT guarantees at least 1. Now this is at least 1. Oh, we've been using c up there, but our x-axis here is time. So at least 1 time, right? Actually, from 1 to 4, there's actually got to be another one between 4 and 6, but it just said at least 1. All right, so such that the velocity equals 0. We are done. So when you practice these, the first ones might be kind of rough. Have your the keys in Schoology and check it. Like after you do the first 1 or 2. Those of you at home who are done with notes, the assignment is linked. It's not that one. That one. Here it is. All right, and maybe we'll do one together. Just to everybody go do number 1, and then we'll check. Okay. Go do number 1, and then she'll check. Okay, here you go, L. D, L, Peyton, I'm getting names of Harrison, Alicia, and Harper. All right, we're all on the worksheet, and you might want to pause the video. I'm going to let them write out number 1, and then we're going to see how it goes. Yep. I didn't want to know. Sorry. So at home, pause the video, go try number 1 on your own. We're going to talk through it, but then for the other ones, you might want to check with the key, just to make sure you're writing it correctly. I'm done at 25 after your schedule. I think it's 27 minutes. Oh, you guys might finish. We'll see. They always look longer than they are because I give you tons of workspace. The reason I'm doing number 1 is for the last part where it says to find the 0. Yeah, it is by accident. Yeah, you can take that off. It's actually just one. I remember that. It's just the 1 page. Yeah, they said it's really just this. I don't know. I got an extra slice. I remember when it came off the copier, and I'm like, I'm not going to rip all those pages off. So yeah, it's just the singleton. And if you brought your calculator, you should take it out for how we're going to answer the last part of number 1. That's why I'm doing number 1 with you. raise your hand when you're to the part where you're on the, and find it if it exists. Got 2, 3, 4, 5, 6, 7, 8. All right, it looks like most of you are there. So again, here's how the IVT works. I know that's what it is because it says has a 0. It's an existence of a 0. Remember, that's of y equals 0 or an x-intercept. So let's go take a look. First thing you do when you look at it is check for continuity on the interval that passes that test. If it didn't, I'd immediately stop and say no, right? Discontinuous at x equals whatever in the interval. You like when that happens because it's shorter. All right? This passed the continuity test. So the second thing you should have done is said, just show me a little scratch work. You're evaluating what's happening at each end. When you put in a 0, you should tell me you get out a -1. When you put in a 1, what am I getting? A 2, correct? Does what I'm trying to guarantee fall between those? Trying to guarantee you're nodding here. So yes. So you get to continue. Now it's how you write it. By the way, if it says, does it guarantee at least one C such that f of C equals 3? No. 3 is not between those. All right, so we're nodding. So here we're going to now answer the question. This gets you 1 point. See how you did. Hopefully we're at 3 at least out of 5. We're going to answer the question, yes. We are guaranteed a 0. We're going to say since, don't say it, f is continuous, and this is continuous for all real numbers, so you don't really have to put on the interval, but let's do it. On 0, 1. Okay, there's another point for the continuity. And 0 is between f of b and f of a. There's another point, right? How are we doing? Good? Then what do you state? Go ahead, Blake. What's next?
The IVT
Perfect.
guarantees.
The IVT guarantees. That's another point. So we're now at 4 out of 5. How many of you hit those 4? Good. What doesn't guarantee? This is the one that sometimes, remember with the driving, with the temperature set, it guarantees at least one time. That's an X, right? So at least one, you could say X value, but we always say C on the interval such that. And what do you write? What does this guarantee? At least one X value such that. See, I see some people erasing. It happens every year. It's this last point that's a little tricky. Such that what? There we go. F of C equals 0. Now it says to find it. Well, you're going to have to use a calculator because this doesn't factor. So you're looking, now, again, if it factored, I'd expect you to do it without a calculator, but you're going to be able to use a calculator on this. And your calculator actually uses the IVT. So take out your calculator, and your y equals, go ahead and enter that. Your calculator's looking for a sign change in the interval that you squeeze that point in. And if you don't see one, I want to show you what your calculator says. So enter x cubed plus 2x minus 1. Let's get that. Okay, your 0 that's being guaranteed is right here. Remember, if it's been a while, you hit the second calc, and choose the 0 option. It's going to ask you to get a left bound and a right bound. And I don't know what the answer is. What is it, guys? Point what? 4. Thank you for going to 3 decimal places. Usually that's not ingrained yet. We're done with that one. You guys go ahead and work. The keys in Schoology in the folder that says keys. If you feel like you're not quite sure if you're writing them correctly, you have 20 minutes left.